Hey, Evan. How are y'all doing today? Y'all want me to good. Y'all want me to work through the ones that we were doing? Oh, I'm doing pretty good. Doing pretty good. Thank you for asking. Do y'all want me to work through the problems from yesterday? Okay. Um, Let me hold on. What I think I'm gonna do, um, I've got the book pulled up here, but I don't think I can write on it from there. Um, so I think, yes, we can definitely work through the elimination for sure. Um, Hey, Lily.
Hi, Miss Sparks.
How are you, sweet girl?
Good. How are you?
Good. Um, Evan and Natty Grace joined us, and we're actually going to work through some of the problems we were doing in class yesterday. And we're going to start with the elimination and work backward toward substitution, just so that you know what we're going to do, okay?
Okay, I'll go get my book.
Okay, sweetie. I'm pulling it up anyway. And like I said, I'm going to pull my book up um, on one of my computer screens, and um, and then work it on a PDF over here. So let me just pull up a blank PDF. Okay. And let me share it. All right. Okay, well, I'm going to start with 13 wasn't one of the elimination one. I mean, wasn't one of the ones that I omitted, right? So I've got 8x plus 3y equals negative 9. And then I've got a negative 8x plus y equals 29. So those are my two equations for this system of equation. And the goal is to eliminate one of them in order to isolate one of the variables. Because you can solve a problem with one variable in it, but you can't just solve for one of the variables if there's two in it. So that's why you want to get rid of one. So in this case, what you always want to do when you look at the linear equations is look for two coefficients that are either the exact same or they're opposites. And in this case of these two, the x's have an 8 and a negative 8. So those coefficients are opposite of each other. And since they're opposite, what we'll do is we'll add the two linear equations together. And they're lined up one on top of each other. It's all nice and neat. So you've got 8x plus a negative 8x, and that cancels out and gives you 0, which was our goal. That's why it's called elimination. You're trying to eliminate one of the variables. Then you've got 3y plus 1y. That's going to give you 4y equals. And then you've got a negative 9 plus 29. So that's going to give you a positive 20. Now you've got just one variable. It's a regular linear equation. So you'll divide both sides by 4. And that gives you y equals 5. Now you'll take that variable and you'll substitute it back in. So you're going to kind of default back to good old substitution in this second part. And you can use either one of the equations. So I'm just going to do 8x plus, and I'll substitute this value for y. So I've got the coefficient of 3. I have to write that. And then I'll put what the variable's value is. Since we figured out what the value is, we'll substitute that value back in for the y, and then equals negative 9. And now I've got 8x plus 15 equals negative 9. And now I'm going to subtract 15 from both sides. And that's going to leave me 8x equals negative 24. And then that divided, 8x divided by 8. And 24, that leaves me an x on this side. I'm going to write it over here. Sorry about that, guys. Equals negative 24 divided by 8 is negative 3. So my ordered pair is negative 3 and 5. Just giving everybody a chance to kind of get that caught up. Oh, I don't want to save that like that. I just want a blank piece of paper. I hate erasing. Did that make sense? Does anyone have any questions about that?
No, ma'am.
Okay. It takes me a minute to erase, guys. I'm really sorry. And so then I'll move on to, I think the next one, what is 14? Is that where I am?
Yes.
Okay. I just lost my place on my other computer. Probably should just pull my book out. It would be so much easier. Okay, the next one is x minus 5y equals negative 3. And 3x minus 5y equals 11. Okay, so on this one, once again, what you want to do is you want to look at the equations and see if you either have opposites or exactly the same coefficients on one of the two variables. And in this case, we have a negative 5 on both of the y's. So we've got the exact same coefficient on them. So last time, because we had opposites, we added the linear equations together. But this time, because we have the exact same, we're going to subtract them to get 0. Okay? Does that make sense? So if you have the exact same, it's like if you have 4, in order to get a 0, you would want to subtract 4. So when you have opposites, you can add them, because a 5 and a -5, when you add them together, give you a 0. But when you have a 5 and a 5, you have to subtract them to get 0. And that's the same exact thing with negatives. You would have to add them to get 0. So what I'm going to do then is I will do x minus 3x. That's going to give me a negative 2x, because this is a positive 1x minus 3x is a negative 2x. And then minus 5y minus a minus 5y. That's technically saying minus 5y plus 5y is going to give me 0. That actually cancels out. Okay? And then negative 3 minus 11 is going to give me negative 14. Does everybody see that?
Yes.
Okay. So this gives me a negative 2x equals a negative 14. I'm going to divide both sides by negative 2. And I'm going to get x equals 7. And then I will take that x and I will substitute it back in to one of the two equations. Doesn't matter which one. I'm just going to pick the first. And I'm going to plug in this value of x for the x. So I've got 7 minus 5y equals negative 3. So I'm going to add, my bad. I'm going to subtract 7 from both sides. This gives me 0 there. Minus 5y equals a negative 10. Divide both sides by 5. And that's going to give me y equals 2. So my ordered pair for this one is 7, 2. Okay? Any questions about that so far? So basically what you're trying to do is get your variables somehow, some way to either be the same or the opposite of each other so that you can add or subtract the two linear equations to get where you just have one variable so you can solve for it. Then once you solve for it, you use that value to substitute back into the one of the two earlier equations so you can get a value for the other missing variable. All right, number 15. The two equations are 4x plus y equals 17. And then the second one is 7y equals 4x minus 9. Well, first of all, we need to get those things lined up because they're not lined up. And in order to do this, you really need all of your variables to line up. So the easiest thing to do in this particular case is to put that second equation into standard form. So that then would look like me subtracting this 4x from both sides. So I would, oops. I think I'll erase that. So I'm going to do minus 4x minus 4x. So then that's going to be negative 4x plus 7y equals negative 9. Now I'm going to take that first equation. I'm looking at it and I'm already seeing, oh, I like what I see already, because I see that now that I've rewritten this second equation, I've got a negative 4x. And then in my original first equation, I've got a positive 4x. So I already have those opposite coefficients that I'm looking for. So I'm kind of excited. So I can just bring down that 4x plus y equals 17. So I've got on that x variable, I've got opposite coefficients. So now I know I can add both of the linear equations in order to eliminate one of the two variables, because I have opposite coefficients on that x. So I'm going to add the top one and the bottom one. So negative 4x plus a positive 4x is a 0, just what I was going after. And then a 7y plus y is an 8y equals, and then a negative 9 plus 17 is going to give me a positive 8. I'm going to divide both sides by 8, and that's going to leave me with y equals 1. So then I'll take this value of y equals 1, and I'm going to plug it in to one of the two equations, and I'm actually just going to plug it back into that top one. So I've got 4x plus, and there was a y there, so I'm going to substitute this value of y in for the y itself, equals 17. Now I'm going to subtract 1 from both sides, and that's going to leave me 4x equals 16. I divide both sides by 4, and that's going to leave me x equals 4. So my ordered pair is going to be 4, 1 for this one. Any questions so far?
No, ma'am.
Okay. Hey, Lily?
Yes, ma'am.
If Evan or Natty Grace pop something up in the chat window, would you mind reading it to me? Because I can't see the chat window when I'm writing. So would you mind being my reader for me?
Sure.
Thank you. Is your chat window open?
Oh, yes.
It is? Okay. All right. Okay, number 16.
Evan says he'll be in and out for a while because his Wi-Fi doesn't work.
Oh, okay. Wi-Fi. It's a blessing and a curse. Okay, 3x plus 2y equals negative 5. And then x minus y equals 10. Okay. Now on this one, neither one of our coefficients are even close. They're not opposites, and they're not the same. So we're going to actually have to multiply one of them in order to get it to be the opposite or the same. So obviously the easiest one to probably do is going to be the latter one, the second one. And I would, since you've already got a negative on the y, I think I would go with multiplying that whole thing by 2 in order to make my y be an opposite. Does that make sense to everybody? Because if I multiply this whole thing by 2, if I do So if I multiply that whole thing by 2, I've got 2 times x, and then 2 times a negative y is going to give me a minus 2y, and then 2 times 10 is 20. Okay, so now that's that second equation rewritten with everything multiplied by a 2. Now, just to make it a little easier to add and subtract, I'm going to come down and rewrite that first equation so that they're perfectly lined up right next to each other. So maybe it'll make it clear exactly why I did it. Now, look at my y's. Those are opposites of each other, right? So that's why I multiplied that second equation by that 2 in order to create that situation where the y's are opposite of each other and they will cancel each other out or eliminate each other. And that's going to give me 0 right there, which is the goal if I add these two together. So 2x plus 3x is 5x equals, and then 20 plus a negative 5 is 15. I'm going to divide both sides by 5, and that's going to give me x equals 3. And then I'll take this x and substitute it back in to one of the original equations. And I'm just going to go ahead with the second original equation just because everything's a little smaller. So I'm going to plug in that 3 for x minus y equals 10. And then I've got a minus y if I'm going to subtract 3 from both sides. And that's going to give me a 7. So minus y equals 7. Divide both sides by negative 1. And that's going to give me y equals negative 7. So the solution, the ordered pair that's a solution for this one is 3, negative 7. One of the things about elimination, and I don't think the ones on the test are all that bad, but the one thing about elimination is trying to figure out in your head which one are opposites and which ones, are the same, or how could I create them, or what's the easiest way to create opposites by multiplying. And that's really what you're looking for. Okay, number 17. 3y equals, oops, my bad.
Natty Grace left. She had to go to dance.
Oh, okay. Thank you for letting me know. Okay, 3y equals x plus 5. And then negative 3x plus 8y equals 8. Okay, now these are they're not both in standard form. So you definitely want to get them in standard form or in some sort of form where the x's are lined up and the y's are lined up and your constants are lined up. So the first thing we're going to do is take that first equation up here and get it in standard form. So we would have to move this x, right, by subtracting minus x from both sides, plus 3y equals 5. Do you see where I got that? Lily?
You subtracted the x from the top?
From both sides of the equation. Just like if you were, putting it in standard form, that would cancel that out. So now you've got a negative x plus 3y equals 5. Mm-hmm. Does that make sense?
A little bit.
Okay. Should I do it down here?
That would make more sense. Thank you.
Okay, so what I'm trying to do is get the x over to the other side. So to do that, I have to subtract x from both sides. So now I've got negative x. And what's the understood sign in front of here?
1. Well,
Understood sign. When there's no sign, it's a
um, I don't.
positive or negative if there's no sign.
Oh, negative.
If there's no sign,
Oh, positive.
yes, plus 3y equals 5. So that's where I got that. See?
Mhm.
Does that make more sense?
A little bit, yes.
Okay. But just basically what you're trying to do, you can't just move a variable to the other side of the equation. It will become the opposite of whatever it is when you move it back and forth. Okay? You know, just like when you're moving it to slope intercept form and all of that stuff, it will be the opposite. So now we have them in standard, both of them in standard form, but they're neither one of them has opposite or the same coefficients, do they?
Mm-mm.
Okay, so what do you think we should do to get them to be either the same or opposite?
Multiply.
Okay, multiply which one?
Um, the y.
You're going to multiply the whole entire equation by something. Which
The
one would be easiest? What do you think is going to be the easiest to make the same?
the 3
On which one?
for the bottom equation.
Okay, so you want to multiply the bottom equation by 3?
Mm-hmm.
Is that what you're saying?
Yes, ma'am.
Good job. Okay, so we'll multiply that bottom equation by 3. And that would give us a negative 3x. And then 3 times 3y is 9y. And 3 times 5 is 15.
Mm-hmm.
And then I'm going to rewrite that top equation, okay, down below it so that they're all lined up. Okay, now that they're the same, since the coefficients are the same, I have to subtract them, right?
Mm-hmm.
So when they're opposite, you can add them, and when they're the same, you subtract them. So I've got a negative 3x minus a minus 3x, which is going to cancel those two out, right?
Mm-hmm.
Okay, now I've got a 9y minus 8y, which is y.
1,
And then 15 minus 8, which is
7.
good job. So now the value of y is 7. So I can plug that back into either one of the equations. And I'm just going to pick the bottom one. So negative x plus 3 times, what's the value of y? 7
Mm-hmm.
equals 5. Because I substitute in the value of y where there's a y.
Right.
So I've got negative x plus 21 equals 5. Now I'm going to subtract 21 from both sides. That's going to give me a negative 16. So I've got a negative x equals a negative 16. If I divide both by negative 1, x equals 16. Did you ask a question, sweetie?
Why would it? Why would it? Why would you divide it by a negative?
By negative 1?
Uh-huh.
Because I'm trying to get rid. See how it's negative x?
Mm-hmm.
Okay, well, I want it to be a positive x. So if I divide it by a negative 1, I don't change the value. I just move it to a positive, right? Does that
Mm-hmm.
make sense?
Yes, ma'am.
Because you don't want a negative x. You want to end with a positive x. So that gives you 16 and 7 as your ordered pair. Any questions about that? Or just keep doing more because is it helping?
A little bit, yes.
Okay. Have you got it narrowed down to what you feel like is confusing? Or not?
The multiplication kind of confuses me, but that's
Okay. Do you understand why, or just trying to get it done, or trying to figure out what you're going to multiply by?
trying to figure out what I'm going to multiply by.
Okay. All right. Well, I think that's one of those things that'll just take some practice. Are you working on the packet?
I have a little bit, but not much since we did in class.
Okay. Do you want to continue working on that and not take the test tomorrow? And maybe take the test next Monday?
I think I could take it tomorrow.
You do? Okay. I just don't want you to feel rushed. Okay. Because I mean, I know you were gone all last week and we worked on that packet all last week. So, okay. So, let's see. Here's number 18. 6x minus 5y equals 9. And then 9x minus 7y equals 15. Now, this is definitely one of those, Lily, where we're going to want to multiply. We can't just cleanly multiply the top and the bottom by one thing and it be okay. Like the last one, we were able to multiply by 3 and it fixed everything on one of the equations. Well, that's not going to work out here because I can't think of, obviously, I can't multiply 6 times anything to get me a 9, right? And I can't multiply a 5 by anything to get a 7. I mean,
Right.
there are those things in the world that would do it, but they're fractions, and I know that you all don't want to do that. So, and then it's just going to make everything else a little more complicated. So what happens in this case is it's almost like back in the day when you're looking for a common denominator. So what we're going to want to do is look at that 6 and that 9. And what is the smallest number that you can think of that both 6 and 9 go into?
18.
Did you say 18?
Yes, ma'am.
Good job. I am so proud of you, Lily. That takes a lot of people a long time to kind of get that part figured out. So that's awesome. So one of the other things that we can do on top of that, one of the other things, that's okay. Momo says I'm getting too excited. She's trying to listen to her. She's trying to listen to a math video. Anyway, so one of the other things that we can do is we can try to also create an opposite in this situation. And we'll kind of talk about that as we go. So what would I have to multiply 6 by to get 18?
3.
Good job. So I'm going to just put a 3 out front to remind myself I'm going to multiply this whole thing by 3. All right, now down here, if I wanted to create a negative 18 down here so that I would have a positive 18 at the top and a negative 18 at the bottom, what would I have to multiply 9 by?
A -2.
Yes, ma'am. Good job. You've got this. You're doing so good. Okay. Is Evan with us or not with us now?
Not with us.
Okay. All right. So 3 times 6x is 18x. 3 times a negative 5y is a negative 15y. And 3 times 9 is 27. Negative 2 times 9 is what?
Negative 18.
Negative 18x. Negative 2 times negative 7y is
14y.
a positive 14y. Good job. And a negative 2 times 15 is negative 30. So now what I did by multiplying the top by a positive and the bottom by a negative, I created a situation where there's opposites. So now all I have to do is add. So 18 plus a negative 18 gives me a 0. Negative 15 plus a positive 14 is going to give me a negative y equals, and then 27 plus a negative 30 is going to give me a negative 3. This is one of those situations, once again, where I'm going to divide by that negative 1, Lily, in order to get rid of the negative on my y.
So it would be a positive 3?
Yes, ma'am. Positive 3. Now what I'm going to do is take that positive 3 and plug it back into one of the original equations. So I've got 6x minus 5 times my 3, the value 3. I'm substituting the value that we found. 6x minus that. Okay, and I'm going to erase some of this so I can come back up here.
Would it be 4? X equals 4?
What number is this? Yes, it is. Absolutely, you did it. So was it too bad? Obviously, you got there real quick. Sure is. 4 and 3 is the ordered pair that's the solution to that one. Had you already worked these out, or had you not finished these yet?
I hadn't finished these yet.
Okay. And you and I were working on substitution in class yesterday. Did you want me to do some more of those? Or do you want to work on the packet together?
Probably do more of those.
More of the substitution?
Yes, ma'am.
Okay.
Is Mackenzie feeling any better?
Well, thank you for asking. That's really sweet. We took her to the doctor this morning, and they gave her an antibiotic and an inhaler. So, and then she came home and took one of the antibiotics and fell back asleep. And she said she felt a little better after her nap and the antibiotic. So
that's good.
So I think we're on the turn of it, but she's been up and down for about 2 weeks. It's been bleh.
Oh,
Which one do you want me to start with? Because I think, what did we do together in class today? Yesterday you and I did 7 and 8, right? And didn't you do 9 or no?
We did 7, 8. Yeah, we did 9. Yes.
Okay. Should I start with 10 then? Or do you want me to start with 9?
I did 10, it looks like. Yeah, I did 10 and 13.
Okay. Because we were supposed to omit 11 and 12.
Yeah. I didn't do 11 and 12. I just did 10
So
and
you did 7, 8, 9, 10?
Yes.
Okay. And then today we did 13 through 18. So do you want me to do some of the solve by graphing, but do them by using substitution just so you can see some more?
Sure.
Okay. Well, what I'm going to do then is just start with number 4 And instead of solving it by graphing, I'm going to go ahead and solve it by substitution. Is that okay?
Yeah.
Okay, so here are the equations. Okay, so what I would do in this case, Lily, is I see an x that's all by itself. So that I'm not having to divide or anything, what I want to do is just get that x all by itself so that I can see what quote unquote x equals. So in order to do that, I would subtract 2y from both sides.
Okay.
So that would give me x equals negative 2y, whoops, my bad, plus 4. So this tells me that this is what x equals. So anywhere there's an x, I can substitute this value.
Mm-hmm.
Okay.
So would you solve for the top one by doing that, the 5x minus 4y?
That's it exactly. That's it exactly. So I'll take this 5, which is the coefficient on the x, and I'm going to substitute this value in for the variable x, because this tells me that this is what x equals. So anywhere in this system of equation where I see an x, I can use this value. And the reason why I want to do that is because I can't solve an equation with two variables in it. I can only solve an equation with one variable to get one value. So that's why I want to do that. So now the only variable that's in this equation, I've got a y here and a y here. That's something I can work with. It's going to take me a minute because I have to do some distribution and some combining of terms, but that's the reason why you're substituting, to get it down to one variable. So I've got a negative 10y, and then because 5 times a negative 2y is negative 10y, plus 20 minus 4y equals 20. And so negative 10y minus 4y is negative 14y plus 20 equals 20. And then I'm going to subtract 20, and that's going to give me 0. Don't panic. 14y equals 0. I would divide both sides by 14, and y equals 0. Then what I would do after I do that is I would plug in this y here in for, I could plug it in either one, but I've got x plus 2 times 0 equals 4. X plus 0 equals 4. X equals 4. So my ordered pair is 4, 0. Does that make sense?
Yes.
Okay, good. You want to do some more?
Sure.
I tell you what I'm going to do. Since the bottom ones, like 19 through well, there was only one. the bottom ones, the 19 through 24, we were supposed to tell if there was infinite number of solutions or no solutions. And you could work them, tell whether the linear system has one solution, no solution, or infinite many solutions. You could work those any way you wanted to find out what the answer is. Mm-hmm. So I'm just going to start on 19. Have you done those already?
No, ma'am.
So I'm just going to start on that one, and I'll work these with substitution so you can see on all the ones that I possibly can, so you can see some examples for substitution and get this and then review review the work at the same time. Does that make sense?
Okay.
So this is number 19. So this is telling me that y equals 5x minus 4. So that means in the previous linear equation, anywhere there's a y, I can substitute this value in because that's what y equals. I can substitute this in for y. So I would rewrite that 15x minus 3 times, what's the value of y? 5x
minus 4.
Yes, so you substitute that in for the y. Okay?
That
Equals
makes
12.
sense.
Okay, good. All right, and then once you've got it substituted, you can see we only have one variable in this whole linear equation, which makes us be able to work it. So we've got 15x, and then minus 3 times 5x is minus 15x minus 4 equals 12. And 15x minus 15x is 0, minus 4 equals 12. So that does what?
Wouldn't both things be 0? Like if you subtracted the 12?
Yes, this would be 0. Oh, you're right. I see what you're saying. I'm so sorry. It's a good thing you caught that, baby girl. So negative 3 times negative 4 is a positive 12. You're absolutely right. So that changes this, doesn't it? Good catch, Lily. 12 equals 12. And that's a true statement. And when it's a true statement, it means there's an infinite number of solutions. And it also means it's the exact same line. Okay?
Mm-hmm.
All right, so that was 19. Has anybody else joined us?
No, ma'am.
Okay. Okay, and I'll do number 20. Okay, so we have 4x minus y equals negative 4. And then negative 8x. And actually, plus 2y equals 2. So on this one right here, I see a y kind of by itself with no extra coefficients. So I kind of feel like that's going to be the best one to rewrite so that I can get an isolated variable so I can figure out what y would equal. So what I would do on that is, I'm going to do this work down here for you. 4x minus y equals negative 4. I'm going to subtract 4x to both sides, from both sides. That's going to leave me a minus y equals negative 4x minus 4. And then I'm going to divide everything by negative 1 because I need this to be positive. Okay? So y equals, and then negative 4x divided by negative 1 is going to be a positive 4x. And then a -4 divided by a -4 is a +4. So this is the value of y. So anywhere there's a y in this second equation here, I can substitute that value in. So -8x plus 2 times, and what's the value of y? 4x plus 4 equals 2. So I've substituted in the value of y into this second equation here. And now I only have one variable in this whole string. So I distribute this 2. And I've got a -8x plus 8x. Those are going to cancel. And it's going to leave me with 8 equals 2. That is not true, which means there is no solution. And it means that they're parallel lines. Okay?
Okay.
Does that make sense?
A little bit.
Is it getting better? Or not really? Huh?
A little bit, yeah.
A little bit? Okay, which part is confusing? The no solution part or the substitution?
Yeah. Like the substitution still confuses me a little bit.
Oh, it's okay. It's still confusing you a little bit? Okay. All right. And is that because is it because you have to isolate the variable, like get one of the variables by themselves, or is it the actual substitution?
I think just getting the variable by itself.
Oh, okay. All right. Let's talk through that a little bit better on this one then. All right. So we've got a -12x. This is number 21, by the way, plus 3y equals 18. And then 4x plus y equals -6. So if we wanted to get the y by itself, or technically put it in slope-intercept form, what would I do? And which one would be easiest to do that with?
The first one.
You think it would be easier to do it with the first one?
No, the second one. Sorry.
Okay, no, that's okay. I mean, it technically wouldn't be bad with the first one, but I just was curious why you would say that. I didn't know if you saw that the 3 was divisible all the way across or what. Anyway, so if we did the second one, since the y is really already by itself, what would we do? What would we have to do to get the y on one side of the equation all by itself? What would we do?
Subtract it.
Subtract what?
The y from the 4x.
Okay. It would be easier to leave the y there and subtract the 4x, right? Because you want to bring this over here and leave this alone. Does that make sense? Or no, not really?
Kind of, yeah.
Okay, because I was going to say, if I do this, if I subtract y, then I'm going to have a y with a 6 now.
Yeah. Okay.
Okay. So that's why I want to get, since I'm trying to leave the y all by himself. So I'm going to subtract the 4x from both sides. Like that. And now I actually have a value for y. It's telling me this is what y equals, -4x minus 6. So now what I can do is substitute this value back in. So let's just talk about that. So this
you would multiply why that times the 3 in the other equation?
Yes, because you're substituting the value of y in for y. So see where this y is here? Instead of writing y again, I'm going to write this value of y here. And the reason why I'm going to do that is because now this equation here only has one variable in it. It's an x. And that way I can solve for x. So I've got negative 12x plus, and now I've got 3 times negative 4x.
Wouldn't it be infinite number of solutions?
On this one? I don't know, because I've got 3 times a negative 4x. So that's a negative 12x, right? Plus a negative 12x. And then 3 times a negative 6 is going to be negative 18. So I've got negative 24x minus 18.
Oh, okay, I got the wrong answer.
18. It's not a pretty answer, though. I'll give you that. It's going to be 36. So it's a negative 24x equals 36. And then I divide by negative 24. And that's going to be I'll say it, 6 goes into that makes 6 times 3 halves. And once you get x equal to something at that point, Lily, then you would substitute it back in, you know, to find out what the other one would be. But on this, you can kind of stop here, because if you get an x, you know there's going to be a y, and it's going to be one solution. For this, I mean, you wouldn't have to give me what the solution is. You would just have to answer the question as one solution. Does that make sense? Okay, because I won't put you through the fractions, since we're just trying to understand the substituting, okay? I don't want to get real confusing with that, but that's what you would do. You would take that 3 halves, which really isn't that big of a deal, especially in this particular one. It wouldn't be too bad. Sorry, I have to answer Miss Stone. Okay. Let's see. Sorry about that. I had to Miss Stone and I were going to try and do an Algebra 2 math lab at 4:30, but what? This one's going to be a no solution one. I'm trying to look for. Hey, Lily, do you care if we just rework 7, since those are more designed for substitution? Any of these will work for substitution, but do you care if we do that? Just because I'd like for you to tell me what to do.
Sure.
And this will be a second go round for us on this, just to make you feel more comfortable. So I'm not going to write anything unless you tell me what to write. Is anybody else with us?
No, ma'am.
Okay. So that way you can just talk away. Okay. So now what will I do?
You would substitute the 5x minus 7 in with
Yes, absolutely. So I write negative 4x plus
5x minus 7 equals negative 1.
equals negative 1. Good job. Does that make sense to you?
Yes.
Okay, so negative 4x plus 5x is x minus 7 equals negative 1. And I'm going to add 7 to both sides.
You get x equals 6.
Good job. So then I would take that x equals 6 and I would plug it in.
And y would equal 23.
That's it. Exactly. All right, let's try number 8. And let's think about this. When I write number 8, look at it. It says x equals y minus 11. And then x minus 3y equals 1. I lost my place on my page. Okay, so now what could I do on this one?
Would you do 3 times the 11?
Not on this one, because what is it telling me here? Read that.
X equals y minus 11.
So that means that x equals y minus 11. So that means anywhere there's an x, I can substitute y minus 11, right?
Oh, okay.
Does that make sense?
Uh-huh.
So it's whatever that variable is right here. That's what you're substituting. Whichever one is all by his lonesome, that's what you're substituting in. Because because I couldn't substitute this in for that because this is telling me that that's a y, and I can't substitute the y because this is telling me that x equals that. So where there's an x, which is right here, I'm going to substitute this. So y minus 11 minus 3y equals 1. So in this case, I don't have x's all by themselves. I have y's all by themselves, right? But I still only have one variable. That's the whole goal, to just get one variable in there. So what's y minus 3y?
2y? Negative 2y?
Yes, ma'am. Negative 2y minus 11 equals 1. And then I'm going to add 11 to both sides.
And then you get y equals negative 6.
Good job. So then you would substitute that negative 6 back in to one of the equations. So x equals negative 6 minus 11, because you're substituting that back in. So x equals negative 17. So the ordered pair is negative 6, negative 17.
Wait, was that number 8?
Yes, ma'am?
Okay. On that one that I think we worked that one together yesterday. We got negative 14, negative 3.
We did? Well, we were wrong. Lord only knows what I did. What did I do?
I don't know.
Huh. I don't know. I know this is right though.
Yeah.
I don't know what I did wrong. Does it make more sense to you yet?
A little bit, yes, ma'am.
Okay. Oh, I dropped my stylus. Sorry. Okay, let's do. Let's do number 9. What time are you leaving to go tonight?
I think around 6.
Do we have time for a couple more?
Yes, ma'am.
Okay. Number 9. Okay. All right. Which one would you want to isolate this time?
Probably the bottom one.
Okay. And what would you do?
You would add the y to both sides.
Okay. Sounds like a plan to me. That's an ad, by the way. Okay. So now I've got x equals y plus 7. So that tells me wherever there's an x, I have to substitute y plus 7. So how would I substitute that back into that first one?
You would do 3 times y plus 7 equals negative 19.
Did I write it how you wanted me to?
Yes, that makes sense.
Okay. So 3y, because I'm going to distribute this 3 now, plus 21, because 3 times 7 is 21, plus y equals negative 19. 3y plus y is 4y plus 21 equals negative 19. Subtract 21 from both sides. And I'm going to get 4y equals negative 40. Divide both sides by 4. I'm going to get y equals negative 10, right?
Yes.
Okay. So then I'll take this y equals negative 10, and I'm going to substitute it back in to one of the equations.
Do you get x equals negative 3?
I bet I will. I'm going to look over here and see. Yes, that is the answer. Good job. So x minus a minus 10 equals 7. So x plus 10 equals 7. And so the final solution is negative 3, negative 10. You're doing good. All right, we have one more substitution one to redo. Is it better now?
Yes, ma'am.
Okay, good. Do you want to do another one?
Sure.
Or are you good? Okay. You just let me know. You know, Miss Sparks can do math all day. All right, so this is 15x plus y equals 70. And then 3x minus 2y equals negative 8. All right. Which one would you do this time?
I think the top one.
Okay. All right. And what would you do?
Subtract the y.
So you would do, so that's what you would do if you had it. So we still don't have one all by itself.
Mm-hmm.
So what else could you do?
I meant to subtract the y from the other side, like
You mean to
the
get
y.
the 15, you want to get the y by itself, so subtract the 15x?
Uh-huh.
Okay, I got you. So that would give us this. Like that. That's what you want?
Yes.
Perfect. Okay, so now anywhere there's a y, I can substitute this negative 15x plus 70. So
Uh-huh.
3x minus 2, and then there's a y there, so I'm going to plug in this negative 15x plus 70 equals negative 8.
Uh-huh.
So now I'm going to distribute negative 2 times a negative 15x is a positive, Lord help me, positive 30x. Negative 2 times 70 is a negative 140 equals negative 8. So we've got a 33x minus 140 equals negative 8. So you're going to add 140 to both sides.
Do you get 132?
Yes. And then 132 divided by 33 is 4. So now you would take that x and substitute it back in that value of 4 and substitute it back into one of the equations. So 15 times 4 plus y equals 70. And 15 times 4 is 60 plus y equals 70. And y equals 10. So the answer is 4 and 10.
Uh-huh.
All right. We'll do one more in the that works for substitute. Did we do this like for the graphing that are substitution? I was trying to think.
I don't think so. Yesterday.
Okay. I know I think I'm going to do number 5 and let's work it with substitution instead of graphing. Just to see, to make sure you're clear on this, okay?
Okay.
Because that way we will have done about 6 problems that way. All right, so which one would you pick to isolate the variable? To isolate one of the variables?
For which numbers?
The ones that I have on up there right now. I think it's number 5. Do you see it?
The second one.
Okay. And what would you do?
Add y to the 2x.
I'm like this.
I like to where the two x's to get the y by itself.
Oh, okay. So subtract the 2x.
Uh-huh.
Okay. Oops. Now you can't have that negative y. So what can I do?
Divide it by the negative y.
Divide it by a -1.
Mm-hmm.
Divide everything by -1, which essentially changes every single one of those signs. So now that would look like the -2 becomes a +2x, and the +4 becomes a -4. So now I have a value of y equals 2x minus 4. So anywhere there's a y, I can plug in this 2x minus 4.
That would be x plus 2 and then equals, can't see the top number.
So is this what you said? Because you broke up just a little bit, and I just want to.
Oh, yes,
Is that what you said? I'm sorry. Equals 9. Is that what you got? X equals 3?
Let's see. Plus 3. That makes sense.
Okay, were you following along with me?
Like, I didn't solve it, but I can look at it from here, and it makes sense.
Oh, okay. I didn't know if you were following along, and I kind of skipped a step, and I didn't know if that made sense or not. Did it? Did that me skipping that step make it bad?
No.
Okay. And then x equals 3. All right, so then you would substitute that 3 back in anywhere there's an x. So 2 times 3 minus y equals 4. 6 minus y equals 4. Minus y equals -2 because I subtracted a 6 from both sides. And y equals 2. So the answer is 3, 2. Does substitution feel better for you
Yes, ma'am.
than it did? And
Yes.
did working all those problems on elimination help?
Yes.
Okay. So if you feel ready for the test, you can take it. If not, just keep working on your packet and make sure you bring your packet to school tomorrow, and you can work on that during the test. And if you wanted to, I don't know, are you taking a bunch of tests on Thursday?
Yeah, I'm making up stuff all week.
Okay. Okay. Well, do you think you'll be able to get the packet finished by Monday or no?
I think so. Yes, ma'am.
Okay. All right. Would you rather take the test then? Or do you want to try tomorrow?
I'm gonna try tomorrow.
Okay. And just see how it goes?
Yes, ma'am.
Okay. All right. Well, that's fine. I'll work with you either way. I appreciate you trying. Okay. Well, I'm trying to think. Do you want me to do any more?
I think I'm good. Thank you.
Okay. All right. Well, if you, like I say, you try tomorrow on the test and we'll see where you are. And, if it doesn't work out really well, we'll work something out. Okay.
Okay.
All right, sweetie. I'll probably see you tonight.
All right. Bye.
Bye bye.